Shanghai in 2026 will once again be the focus of the global energy industry. As one of the world's largest and most influential photovoltaic events, SNEC is expected to bring together thousands of companies from around the world, with an exhibition area exceeding 300,000 square meters. But if you think this is just an ordinary technology exhibition, you'd be mistaken. This is more like a decision-making arena for the future energy landscape. While many companies are still struggling in the quagmire of price wars, some industry giants have already launched a new battle here to end involution. This war is no longer about who can produce the cheapest solar panels, but about who can define the energy rules for the next decade. Chapter 1. Saying goodbye to involution, the emergence of a new trend. To understand this battle, we must first understand its background. Years of involution. This term accurately summarizes the norm in the photovoltaic industry over the past few years' frenzied capacity expansion and the ensuing brutal price war. By the end of 2024, China's annual photovoltaic module production capacity had exceeded 1,100 gigawatts, far exceeding the global actual installation demand of approximately 530 gigawatts, resulting in a severe imbalance between supply and demand. This led to a continuous plunge in prices across the entire industry chain. The prices of many products fell below the cost line for most manufacturers, plunging the entire industry into a predicament of severely squeezed profits and even losses. However, at this year's SNEC, a significant turning point became increasingly clear. Calls for anti-involution within the industry are growing louder. From polysilicon to modules, leading players in the industry chain are beginning to express a tacit understanding on various occasions. They must abandon the old model of simply relying on scale and price to win and shift to competition on a higher level. When quantity expansion is no longer the sole storyline, the value of quality and innovation comes to the forefront. Companies begin to ponder a deeper question. If we don't compete on price, what can we compete on? SNEC 2026's answer is not a single technological breakthrough, but three entirely new battlegrounds. Chapter 2. The front lines of the new battlefield. Three revolutionary forces. Frontier 1. AI energy brain. A leap from power generation to smart electricity use. The first new battleground is at the brain-level artificial intelligence. In the past, when we talked about photovoltaics, we were concerned with the conversion efficiency of a single panel. However, solar power generation is inherently volatile, making large-scale grid connection a constant challenge for the power grid. AI is becoming the key to solving this problem. At the exhibition, we saw not only hardware, but also the intelligent brain that drives them. Companies such as Huawei have launched intelligent photovoltaic and energy storage solutions, covering power generation, the grid, and the power consumption side. One of the core technologies of these solutions is called grid forming. You can think of it as an intelligent grid stabilizer. It no longer passively responds to grid commands, but actively supports the grid's voltage and frequency, providing inertia like a traditional generator to enhance grid stability. When photovoltaic output drops suddenly, the AI system can make decisions within milliseconds, precisely drawing power from the energy storage system to fill the gap and maintain the balance of the entire grid. AI algorithms can even continuously optimize their power generation strategies through machine learning. For example, by optimizing the angle of tracking brackets using AI, power generation has reportedly increased by several percent in some pilot projects. This may not sound like much, but when scaled up to the hundreds of millions of solar panels worldwide, it becomes an astronomical figure. More importantly, AI is reshaping the relationship between energy and computing power. Future AI data centers will be energy-intensive behemoths, and these data centers can be built precisely where solar photovoltaic resources are most abundant, utilizing green electricity for computing and achieving computing power synergy. This means that the value of solar energy is no longer limited to power generation, but will become the underlying energy foundation of the future digital economy. Frontier 2. Space. Photovoltaics. The ultimate vision for gazing at the stars. If AI is the brain of energy management, then the second battleground extends beyond Earth to space. At this year's SNEC, the concept of space photovoltaics was thrust into the spotlight. Companies like Zhongda Technology are actively developing technologies suitable for space applications. Why go to space? The answer is simple. In space, the sun is a super energy source that's online 24/7, unaffected by clouds or day-night cycles. Theoretically, solar power plants deployed in geostationary orbit could continuously receive energy and then wirelessly transmit the electricity back to Earth via microwaves or lasers. This is one of the most imaginative responses to the ultimate question of energy depletion. Of course, this is no easy task and remains a distant concept. The extreme environment of space places extremely high demands on the performance of photovoltaic cells, while the high launch and manufacturing costs are also a huge challenge. Therefore, the industry is exploring multiple technological routes. For example, Zunda Technology is collaborating with research institutions to develop more promising flexible perovskite tandem solar cells, which are theoretically lighter, more flexible, and lower in cost. The booming development of this sector is closely linked to the explosive growth of commercial spaceflight. Over the next decade, tens of thousands of low Earth orbit satellites are expected to be launched globally, all requiring stable and reliable power sources. Looking further ahead, the concept of space data centers also makes space photovoltaics a potential option for extending AI computing power into space. Although the commercialization of space photovoltaics still has a long way to go, its emergence signifies that the photovoltaic industry's imagination has extended from the ground to the stars. This is not only a technological race, but also a matter of future energy security and strategic dominance. Frontier 3, Integrated Energy Solutions, an ecological revolution where everything can be photovoltaic. The third battleground, and the one closest to our lives, is upgrading photovoltaics from a single power generation product into a complete energy solution. This change is evident throughout the SNEC exhibition hall. Fewer booths are simply showcasing modules, while more and more are displaying eco-friendly, full-scenario solutions. A prime example is Skyworth Solar, which transitioned from the home appliance industry. At this exhibition, the company launched a full-scenario photovoltaic and energy storage solution called Superspecies Energy Bright Station, which embodies a new way of thinking. Photovoltaics are no longer installed in isolation on rooftops, but are deeply integrated into every corner of buildings, communities, and life. Imagine this scenario. The railings of your balcony are themselves power-generating glass. The roof of the carport is covered with photovoltaic tiles that can not only charge electric vehicles, but also store or sell excess electricity to neighbors. The entire industrial park forms a self-sufficient green electricity microgrid through rooftop photovoltaics, energy storage, and a smart energy management platform. This is the closed-loop logic of generating more, storing more, and using more proposed by companies like Skyworth. This shift from selling products to selling services and selling an ecosystem is a significant sign of the photovoltaic industry's maturation. It frees users from getting bogged down in complex technical parameters, allowing them to focus solely on how much electricity bill savings and revenue the solution can generate. This is a crucial step in the evolution of photovoltaics from a B2B industrial product to a more user-friendly B2C service-oriented product. Chapter 3. Analysis. The true meaning of the end game. Now, let's connect these three cutting-edge fronts: AI energy brain, space photovoltaics, and integrated energy solutions. They all point to the core of this final battle. The dimension of competition has leaped from the two-dimensional plane of single-point manufacturing capabilities to the three-dimensional space of ecosystem building capabilities. In the past, the evolution of competition was a war of attrition where everyone competed on a narrow track, focusing on cost and scale with no real winners. Now, new rules of the game are emerging. The winners of the future will no longer be the factories that can produce the cheapest solar cells, but rather the companies that can seamlessly integrate AI algorithms, hardware, energy storage, application scenarios, and the financial services to build an efficient, intelligent, and self-consistent energy ecosystem. In this ecosystem, AI is the central nervous system, responsible for perception, thinking, and scheduling. Photovoltaics and energy storage are the strong muscles responsible for the production and the storage of energy. Integrated energy solutions are the tentacles that connect this ecosystem with the real world, reaching into every corner of homes and businesses. Space photovoltaics represent this ecosystem's ultimate exploration of the future's ultimate energy source. This war will eliminate those players with rigid thinking, who only see treasures on old maps. Those ecosystem builders who dare to draw new maps and define new rules will share the greatest benefits of the future energy world. Behind this lies the added challenge of new globalization challenges, such as geopolitics and technology export controls, forcing leading companies to become more independent and controllable in core technologies. As the clamor of SNEC 2026 fades, the blueprint for the future of energy has become clear. This final battle sweeping the global photovoltaic industry is less a brutal elimination round and more a profound evolution. Beneath the smoke of battle, what we witness is not the demise of an industry, but the birth of new species. They are no longer fixated on the minuscule price wars, but instead set their sights on a broader space of value, using AI to reshape the intelligence of the power grid, using scenarios to define the warmth of products, using ecosystems to build a future landscape, and even using the courage to explore the stars and the sea. This is the answer to the final battle. It marks the end of an era reliant on low-price competition and the arrival of a new era based on winning through a smart ecosystem. AI-powered energy brains, space-based photovoltaics, and integrated energy solutions. Which technology do you think will change our world first and most profoundly? Leave your thoughts in the comments section. If you're interested in this ongoing energy revolution, please subscribe to our channel. See you next time.